Hello, Chem 1A. This is Chapter 1, Lecture Video 4, and we're going to be talking about units in this lecture video. So one of the things that you should be aware of, but not really is that important, is the International System of Units. SI units are things like mass is the kilogram, length is the meter, time is the second, amount of substance is the mole. These SI units are what we call the standard units, and they're pretty much what we use when we want to report our results across international boundaries, so that everybody's talking about the same numbers in the same units. Because if I'm comparing kilograms to somebody who's using grams, that can lead to some confusion. But primarily, we don't have to always use kilograms when we're using mass. That's a common misconception. Just because the SI unit for mass is kilogram doesn't mean I can't use grams, milligrams, micrograms. I use whatever makes the most sense based on the amount of substance I'm measuring, or the amount of time, or the length, or whatever. Volume is the liter. We're going to talk a lot about the metric system in this lecture video. So the metric system uses prefixes. It's much better than the standard or imperial system that the US uses, because every different unit is different by a factor of 10, which makes a lot more sense and is a lot easier to understand than something like, hey, there are 12 inches in 1 foot and there are like 5,200 feet in 1 mile. These are kind of arbitrary numbers in a lot of cases, and it's difficult to remember them. Metric system works a lot better in that regard. So the way the metric system works is we take a prefix and we attach it to what's known as a base unit. The prefix can change the magnitude of the base unit, making a smaller unit or a bigger unit depending on which prefix is used. Base units that you need to be aware of are going to be the gram for mass, liters for volume, and meters for length. These are the primary base units that you're going to be working with. So you should know those three at the very minimum. Okay, so here is a table of different prefixes that are used in the metric system. So we have the ones highlighted in red here are the ones I need you to know. So, and what I mean by that is you need to memorize these metric prefixes. So giga, you need to know giga, you need to know its symbol is a capital G, and you need to know its multiplier is 10 to the 9. Mega is capital M, multiplier 10 to the 6. Kilo, lowercase k, multiplier 10 to the 3. I don't need you to know hecto or deca, but I do need you to know deci, lowercase d, 10 to the negative 1. Centi, lowercase c, 10 to the negative 2. Milli, lowercase m, 10 to the negative 3. Micro, nano, and pico, 10 to the negative 6, 10 to the negative 9, and 10 to the negative 12, respectively. These are the prefixes I will expect you to know throughout the class. I won't provide these multipliers to you. I won't provide the symbols for you. You need to be able to recognize them. The other ones, if I do use them, I will give you some information about them so that you know what's going on. So again, the ones in red, they need to be memorized. Okay, so how do these prefixes work? Well, they change the magnitude of the base unit. So for instance, the gram is the base unit for mass, and if we put kilo in front of grams, that makes it a much larger value. 1 kilogram is a lot more than 1 gram. In fact, because the kilo prefix has a multiplier of 1,000, this tells me that in 1 kilogram there are 1,000 grams, because kilo has a multiplier of 1,000. Another example would be milli, 1 milliliter. Liter is the base unit for volume. If we add milli there are 0.001 liters in 1 milliliter, right? Because the multiplier for milli is 10 to the negative 3. We can use these relationships to create what we call unit factors to convert units from one metric unit to another. Now, unit factors are used to convert any unit to any other unit. However, the prefixes in the metric system give us the kind of blueprint for what our unit factor should be when converting metric units. For instance, the unit factor between kilograms and grams could be either 1,000 grams over 1 kilogram or 1 kilogram over 1,000 grams. Now, we would use one or the other depending on what we were actually doing. For instance, if I had 5.6 kilograms, then when I want to use this metric unit factor, I want to make sure kilograms cancel if I'm trying to get grams. Now, how do they cancel? Well, kilograms needs to go in the denominator so that they cancel out. Grams would need to go in the numerator so that I'm left with grams after I multiply by my unit factor. Now I know, because I know my prefixes, that 1 kilogram is 1,000 grams. At this point, I can go, well, kilograms are going to cancel. We're going to be left with 5,600 grams as my answer. All right, so let's move on. All right, so you need to be able to convert units using unit factors. Now, I will provide you standard to metric unit factors like 1 inch to 2.5 centimeters, 1 pound is 454 grams, and so on. Those will be provided. Any standard to metric conversion that you need, I will give you. There are a couple standard conversion factors that I do expect you to know. Time unit factors you should know. For instance, 60 seconds in 1 minute, 60 minutes in 1 hour, 24 hours in 1 day, about 365 days in 1 year. I expect you to know those conversions. I also expect you to know that there are 12 inches in 1 foot. Other than that, I pretty much will provide it for you if it's not a metric unit factor, right? The metric ones, you need to memorize those ones that we had in red in the previous slide. I won't give you those. But the rest, pretty much, I will give you, except for those time ones and the 12 inches in 1 foot. So let's do some practice here. Let's say I want to convert 700.24 grams to kilograms. Well, I need to come up with a unit factor here. Now, when we're doing this, we always want the unit we're trying to cancel to be in the opposite location. So since grams is in the numerator in the 700 value, I need it in the denominator in my unit factor. The unit I want to have is going to go wherever we want to have it. Eventually, we want to have kilograms in the numerator at the end of this calculation, so kilograms goes up top. At this point, it's just the memorization of that prefix. We know there are 1,000 grams in 1 kilogram, so I look at this and I go, oh, hey, this is 7.7024 kilograms is in that many grams. If we want to convert milliliters to liters, this is a very important one. This is one we'll be doing a lot in this class. We know that, again, we want milliliters down here in the denominator. We want liters in the numerator. There's a number of ways you could go about this. You could say, hey, 1 milliliter is 0.001 liter, or you could say in 1 liter there are 1,000 milliliters. I really don't care which way you do it. Memorize it one way, go with that way. At the end of the day, this gives me 0.07632 liters. Okay, so here we want to go from inches cubed to kiloliters. So there is one more factor that I definitely need you to know, and that is 1 centimeter cubed is equal to 1 milliliter. You should have that relationship memorized. Now, if I want to do this, I have 560,000.54 inches cubed. Inches cubed is a big deal here. This cube, we can't just ignore it. Now, we have the unit factor up top that 1 inch is 2.54 centimeters. This, again, just comes from right here. But this doesn't cancel. If you look at our units, I have a cubed here. And that cubed is not going away just because I divide by 1 inch. I need to divide by 1 inch cubed. And that's not going to have the same unit factor. I need to cube this entire unit factor. Well, 1 cubed is 1. So we have 1 inch cubed in the denominator, and then we need to take 2.54 cube that to get cubed centimeters. This will give me some value. What we get here is going to be 9.177 times 10 to the 6 centimeters cubed. The inches cubed here will cancel with the inches cubed. This cubed goes into that unit and onto our multiplier, and we get this value. Now we're not done. This gives us centimeters cubed. I need to take this 9.177 times 10 to the 6 centimeters cubed and go, oh, hey, well, based off this guy, 1 centimeter cubed is equal to 1 milliliter. Then I need to go, okay, well, I need milliliters down here, liters up here. I know that in 1 milliliter there is 0.001 liters. And finally, I can go, hey, in 1 liter, there are 1,000 liters in 1 kiloliter. This will allow me to get to my final answer, which is that there are 9.177 kiloliters in that many inches cubed. All right. Finally, we could go from centimeters to meters. So again, the cubed unit is so important. Whenever we have a cubed or squared unit, we have to square or cube that unit factor. So I have 32.4 centimeters cubed here. I know that in 1 centimeter, there are 0.01 meters. However, I don't have centimeters, I have centimeters cubed. So I need to cube this unit factor. That is going to be a dramatic difference in how we calculate this problem. If this was centimeters squared, I would square this unit factor. And it is so very important that you do this. If you don't, you're going to lose points and get wrong answers. So if we do this calculation, we get 0.000032 meters cubed. And that would be our answer. Oh, sorry, 324 meters cubed. All right, so if you have any questions, as always, please contact me via my email or come to Zoom office hours. I'm always happy to help.